Okay, so what I've got set up here, guys, is just a little analogous model for the AC, permanent magnet, synchronous motor generators within a hybrid vehicle. And I'm just trying to demonstrate the motor function, the drive function, if you will, and how it's actually controlled. So it's a wee bit a steep learning curve to consider how those motor generators are actually driven, let alone considering the regenerative braking function. So maybe this will help. If any of you guys are familiar with variable frequency drives, it's basically the same concept, right? So what we can do is we can control the speed of the motor by altering the frequency, and we can control the amount of torque that is being delivered by upping the voltage. Up the voltage through the coils, obviously you would up the current through the coils, hence delivering more torque to the wheels through the gearbox, of course, right through the power split and the final drive and the differential. So let me just back up here, guys. Perhaps I wasn't clear in that statement. How we effectively change the voltage is by altering the duty cycle. In this case, this little test rig is operating just over 12 volts, right? So at 50% duty cycle, 12 volts would have an effective voltage of 6 volts. If I drop that to 25% duty cycle, it would have an effective voltage of 3 volts. I hope that's clear. My little demonstration here, I've got a little LED, just a light, a little LED, which is analogous of the motor. So it's obviously gonna not rotate, but just give us a flash as a visual indication of how fast we're going. The rate that it will flash will be representative of the speed, and the intensity of the flash will represent the torque that is being delivered. So we can actually, just like the real deal, we can actually apply a frequency and we can actually get the motor rotating, right? But you can see there, we really don't have much intensity, right? We'll have a 1 hertz signal there, so it's flashing at 1 hertz. But if we up the duty cycle, we can effectively, I hope you can see that the intensity is it's becoming more intense there, guys, and that's supposed to represent more torque being delivered. The speed hasn't changed, but the torque has, right? So if we started the wheels rolling and we started accelerating, disregard the momentary steady there, guys. That's just an anomaly. That's just a characteristic of the little control panel there. Now you can see we have higher speed. We're applying a higher frequency. The motor would be rotating at a higher speed. And again, we could alter the duty cycle of that AC signal. It's not an AC signal, it's actually a DC signal that's chopped up to simulate the AC that's being applied to the 3 different stator coils. And you can see we could up the speed and the torque now, and we can keep altering that, and the vehicle will get faster and faster. So this is a gross oversimplification of things, guys, obviously, right? But it does go some way to introducing the concept of the motor control, the motor generator control of a hybrid vehicle. If the inverter with converter would apply a higher and higher frequency to the coils within the motor generators, we'd get higher and higher speed from the motor, again through the power split, through all the gearing to the final drive, to the wheels through the differential. And of course we could go back down doing the same thing till we're near stopped. So I hope that helps. That's it, boys. Just a wee short one. Cheers. We'll get into more detail about the motor control in the future. Just a wee introduction.